So again, welcome to our webinar. And let's go ahead and take a quick gander at the agenda. So we're going to quickly review some of the work we've done with Tecplot 360EX, the design goals, and we'll talk about the beta program. And certainly we have a very active beta program with over 220 or so users now. So after this presentation, if you're interested in taking this technology for a test drive, love to have you online. So, well then, Dave Taflin will be spending some time talking about our new subzone load-on-demand technology. And so I'll be turning it over to him for that. And we'll talk about what the subzone technology entails, some performance results. And we're actually going to spend time showing you how you can create subzone files. And finally, we will have time for Q&A. If you haven't been to one of these GoToWebinars in the past, just a quick note, you'll see on your little sidebar there's an area where it says questions. If you have a question as we're going through, please go ahead and just type it into that box. Those questions will actually come across, we can see them, and we'll try to address them as it makes sense within the presentation. Okay. So very quickly, some of you I think have sat in on some previous presentations around Tecplot 360EX, but Tecplot 360EX is really the most significant upgrade to our technology in the last 10 years. This involves taking Tecplot 360 and more or less rebuilding it. I think we calculated it's about 40% of the main code had to be redone, and so this is quite a rebuild for us. It uses Qt technology and also a little more modular using our internal SDK. As we'll talk about, it improves performance significantly, but the primary focus was performance and ease of use. And ease of use is part of performance in a way. If it's hard to use, the fact that you can load results in quickly is only half the story. You do need to be able to get to the answer as quickly as possible. And there was also a net benefit for people who are using Mac or Linux, in that the new Qt technology gives a much more modern interface. So the key things that we've focused on thus far have been around things like plot style improvements. So we're not going to go through this in great detail, and we've had a couple of webinars about this, and we'll likely have another. But we've implemented context menus for very quick changes of style. We've changed the way you do curve fitting, extracting data, changing style. This all can be done from a context menu, as well as changing how the zone styles dialog works, modernizing it using ability to select zones using text and zone groups. And so we won't talk about that in detail, but we do have some webinars where that's been discussed. We also implemented some changes to slicing, including arbitrary slicing, as well as the ability to extract slices on screen. This is very helpful as we've implemented surface slices, so in a way you can slice along a wing or a body and with one click extract those slices to use them for further analysis and plotting. And lastly, we implemented something called pages, which effectively is much like Tecplot, or pardon me, like PowerPoint, in that it allows a user to create multiple views of one or many data sets in a single layout, and therefore you can actually have a layout which contains line maps, integrated plots that have both line maps and 3D or 3D separately. And this all can be saved in one simple layout, and therefore you can also do data append or data override and have the ability to actually have like almost an entire report automated in a single layout. So we're very pleased with the progress we've made on that. And with that, I'm going to go ahead and scoot out of the way, and we're going to send this over to Dave and Scott, and we're going to talk about some of the subzone load-on-demand technology.
Okay, first a little bit on what motivated this. I'm Dave Taflin, by the way. Disks are slow, and they're not speeding up as quickly as processors and networks are. So over time, reading file off the disk has become relatively a slower and slower operation. So that points us toward a way of improving performance by allowing you to read only the data that you need for the plot that you're doing right now. So we've implemented a query-driven set of APIs that we use internally to access our new file format which allows us to load just the bits of data that we need for the plot at hand. And this reference is an isosurface example. I don't have that one queued up. Do we have that one?
We do if we need it. Yeah, it's okay.
Okay, maybe we'll get back to that. So this changes how the required time to the image you want scales as your problem size increases, and reduces the time to first image, or your image if you're loading a layout, by a factor of up to n to the 2/3, where n is typically the number of cells in your solution. And also reduces, there's a corresponding reduction in the amount of memory that you need to load that layout. Another term for this technology is lazy loading. So here's a picture of how this works. Now, these are 2D images. In fact, we only do this in 3D, but 2D is a little easier to, these 2D images make it a little easier to describe what's going on. Actually, Scott, you want to walk us through this one?
Oh, sure. This is, you can see, just a simple 2D grid. And the idea is, in previous versions of Tecplot, we would load an entire zone as needed. So a zone is just a chunk of data that has been decided by the user or is in the file. And what we do now is we actually break it up into smaller pieces, or subzones. And the subzones are loaded as needed. So, for instance, on the left, you can see we've taken this block.
Maybe let's
look at this one. So on the left, you can see the block of a 2D grid. We divided it into, in this case, 16 subzones. And then we can say that for that contour line, that blue line you see, it really only needs to load the light-colored subzones. The dark ones, you don't have to load at all, and so only 5/16 of the data needs to be loaded. Now, as you mentioned, this is an n to the 2/3 thing, so this is a very coarse grid, and it still has reduced it by a factor of 2. We've seen reductions of, easily an order of magnitude or 2 orders of magnitude in the amount of data that you need to load, so it's a really substantial reduction. And with disks being so slow, that makes a tremendous improvement in both the loading time and the memory requirements.
Okay, thanks, Scott. Here's a particular sample that we've run recently. We have what we call a half trap wing. You can see the picture of the geometry with a slice that we've generated through the data. And then in the table on the lower left side, we have some timings. With our most recent released version of Tecplot 360, this layout took 222 seconds to load with a peak memory usage of just over 20 gigabytes. For comparison, we ran this single-threaded just to show you that indeed 360 as it's currently released is using multiple threads. So we're already achieving a pretty good speed up over running it single-threaded. However, the bottom line shows you the effect of going to the subzone load on demand, where the time to first image is reduced by almost 2 orders of magnitude, and the memory usage is almost as advantageous.
Dave, we have a couple of quick questions. Richard Cook asked quickly, are all the subzones the same size? I think that's what this says. It's pretty hard to read from my vantage point, but...
Yes, the subzones are always the same size for every data set.
Yeah, we use the size of the subzones is 256 cells and 256 nodes. We actually have separate subzones for the cells and nodes, except, there will be one subzone left over that might be smaller. If you don't have this number of cells that's evenly divisible by 256.
Yeah, that's for an unstructured subzone file. If we go to structured, we grab 6 by 6 by 6 cells or nodes, and then whatever you have left over at the extrema of I, J, and K are smaller subzones.
And Richard then followed up with, do you store min-max at every subzone to facilitate? And that, yes, we do. We have a min-max for all the variables at each of the subzones. So, so this is substantially less data than the actual data is. You know, that wasn't clear, but you know, we have there's only one subzone for every 256 cells. So you know, it's 1/100th roughly of the data that you have for your cell data. So it is a little bit of an overhead, about a 1% overhead in storage. Well, we make up for that in some other compression approaches that we take. So actually our files are smaller than they are with, at least for finite elements.
Yeah, and a previous slide mentioned interval arithmetic, which we didn't talk about yet. But for calculated variables, that is let's say you've got a Plot 3D file or data that came from a Plot 3D file originally, so you'll have density, momentum, and total energy in your solution, but you want to plot pressure or temperature. So typically you've calculated that as a new variable in your data set. You'll continue to do that, but you don't want to have to do the calculation over the entire data set anymore. You'd like to be able to just calculate pressure and temperature where you're going to need it, which is a little hard to predict a priori which subzones, let's say an isosurface of pressure is going to pass through. But we take these subzone min-maxes of the input variables, the density, momentum, and energy, and do interval arithmetic to predict which subzones an isosurface is going to pass through. Then load only those subzones, do the calculation, and then calculate the isosurface. So even with calculated variables, we can avoid loading most of the data.
And the nice thing about interval arithmetic is it's a bound on the range of the real range. And so you never have a case where it predicts that a subzone doesn't need to be loaded when it really should be loaded. It's always the other way. So it's always conservative. Yeah.
Okay. So are there any other questions we need to address here before we move on?
No, I think we can move on.
Yeah.
Okay. So here's another test case, 1.2 billion cells, tetrahedrals in this case.
Yeah, on the standard Tecplot, that uses 66.4 gigabytes, and we're going to show you. Are we going to load this now? Okay. Yeah. So in actually in this case, it uses looks like it's. Yeah, we're missing a little bit of data here, but I believe it uses about 2 gigabytes of data with the subzone load on demand.
I think we actually did a webinar on that, Scott, you and I, about late November, early December, and we actually loaded it on the laptop we're working on today. So I mean, that was quite a miracle to be able to load.
We run this test every night, and we load it on machines with the worst machine we tested on is an 8 gigabyte. Is a Windows machine with 8 gigabytes of memory, and it loads in a reasonable amount of time. So this is 2 billion cells, or 1.2 billion cells, and you can do it in a reasonable amount of time.
So to summarize the advantages, we have a faster time to our first plot. If you have your favorite isosurfaces or slices, you'll normally save those to a layout file, so all you have to do is open the layout file with your newest data. So you get to that plot much faster. The memory requirements, as just mentioned, are dramatically reduced. And for unstructured or what in Tecplot parlance for historical reasons we call finite element data files, we get some compression on the connectivity, so they actually tend to be smaller than what I guess I'll call legacy Tecplot data files. It is worth noting that we're not doing subzone load on demand for 1D or 2D data, but those will still be in the file, and I'll mention why in the case of surfaces you'll want them there a little later. So to create subzone loadable data files, we have two methods available to you. If you have existing data, your option is to use Tecplot 360EX itself as your converter. Load it into 360 and then have 360 write out your subzone data file. This requires, of course, a machine that you can load the data on. But remember, for most data file formats, Tecplot these days is using zone or zone variable load on demand, so you're not loading the entire data file all at once, but you are loading entire zones and variables at once. Your second option, and this of course we hope is the future direction, is to create subzone loadable data files directly from the simulation codes that produce the data. And the way to do that is with the TecIO library, which we've updated to output the new file format. We'll talk a little more about each of these options. So converting files using Tecplot 360EX, you can convert any data file that Tecplot can currently read. And although this may take longer, you can also set it up to do it in batch mode overnight or something like that in the case of really huge files. So at least hopefully you won't have to sit there watching it happen. But huge files do require huge machines, so you won't be able to do this conversion on your laptop, and it does take a bit longer to write these out than writing a corresponding legacy Tecplot data file.
Yeah, so Dave, I think one possible workflow you might see is somebody who has a script that they use to run their CFD code could actually, at the end of that script, run a Tecplot in batch mode to generate the file. And so it could be done on a bridge node out near the near a fairly powerful computer out available that's for post-processing, or even one of the nodes of the supercomputer. So that would be how I would envision this working.
Another quick question was brought in. Actually, we have several papers on this subject, 3 of which I believe were published.
Yes, we've published 3 papers on this at AIAA, and we also and the Oversight Conference, and we also have 2 white papers that are actually supersets of those papers that are available for download from our website.
Perhaps we'll go ahead and send out at the end of the webinar to those people who attended. We'll send links to those.
Mm-hmm.
Dave is pointing out that I want to make sure we have enough time to go through the example. So
yeah, no, I'm not worried.
Okay.
I was just keeping track, making sure we're not going to run over. But speaking of examples, let's do a small one. Of course, I had to pick one of reasonable size just so that you all don't have to sit there waiting while Tecplot churns for 5 minutes on a file. So I'm going to convert a small case. The source data here is a pair of Fluent solution files, 1 case and 1 data file. About 50,000 cells, unstructured. The total size of the Fluent case and data files is about 18 megabytes. A classic PLT file, I'll write one of those out first, and then the Tecplot SZ-PLT file. And you'll see that we do get some size reduction.
And Dave, I think in this case, the 20% we're referring to is from PLT to
That's
SZ.
right.
Yeah.
Whereas if you look at it from a case of data standpoint, it's essentially less.
Oops. All right, so let me bring up 360. And this is the beta of the new product now. And I'm going to load the case and data files. And so here we have the crutcher. Now, the way to interactively to write out your Sizzle PLT file now is to select Write Data File, which is what you've always done to write PLT files. Actually, let me write a PLT file first. Tecplot binary data writer, and I guess I'll just drop them on your desktop, Durrell, if that's all right. Okay. So let's call this crutcher.plt, and we'll write everything. Okay. So we've got crutcher.plt on the desktop. Now let's write it as an scplt file. Notice, although, and this may not be obvious to all of you, maybe many of you haven't worked a lot with add-ons, but our subzone loader and writer is all done as a Tecplot add-on. So there's nothing you're seeing here that if you weren't interested in writing add-ons yourself, you couldn't also do. So we've added the ability to register data exporters from 360, and I'm taking advantage of that now with our subzone loader. So I'm going to save this to the desktop also as an scplt file. And the write time was not dramatically different, but it did take a little bit longer, and we don't know if we'll keep that information dialog in the release version or not. But something to notice is the PLT file, the first one we wrote, is about 12 megabytes. It's a little bit harder because we have a bunch of auxiliary files, which in the final product we may all roll together, but these are a fairly trivial size. Here's the main file, and that's about 10 megabytes. The rest of these auxiliary files all put together, this is 12K, so that doesn't add significantly to the file size. But we now have an scplt file that if I go a new layout, notice we've got some droppings here on the screw in the middle of this. You're going to see those disappear in the new file, and I'll talk about why in a second. So I'll not save my layout. I'll load the new scplt format. It's on the desktop. So there it is, crutcher.scplt. And you notice actually a couple of things different here. We don't have any of the droppings on the screw mixing blade here in the middle. And also we've got this orange box around the data. Well, what you're looking at here is only the surfaces. By default for scplt files, we turn off the plotting of surfaces. In other words, we do not by default have 360 extract and display the surfaces or the boundaries of your finite element or unstructured data as the existing release of 360 does. The reason for that is that to calculate those boundaries, we'd have to load all the data, which would immediately defeat the purpose of having subzone-loadable data.
In this case, Dave, I think you're talking about the volume, surfaces of the volume.
Yeah, surface of the volume.
The actual surfaces, like in this case, are clearly visible, and the scplt file does include surface, 3D surfaces. So.
Right. Yeah, that's why we're seeing something. The first 5 zones here are the volume zones, and we're not plotting the boundaries of those zones. What you're seeing are all the surface zones, which were also written to the scplt file. And I mentioned earlier, you really want to do this if you possibly can. Mesh generators commonly will output surfaces as well as the volume mesh if you tell them to, and you want those so that you can see them later without having Tecplot do that boundary extraction, which requires all your data to be loaded. So that was the example of using 360 as your data conversion. And I'm looking for my PowerPoint now.
It's just right there. No, right? No. Yep. You got it.
Okay.
There you go.
But the other option, and the option that I hope will be adopted going forward, is using the TecIO library to write the new data file format directly.
Before we go on, we have a question here that probably should be answered before we do any more. It says, if the fluent file is transient, does an SEL file need to be written for each of the data files, or can it just be done once?
If you load all the transient data at once and then output the sizzle file, all of the time steps will be written to the one sizzle data file. This does bring up a question that I think I'll probably talk about more later, in that the most natural way to output that in Tecplot land would be to output one grid file and then multiple solution files, which really is quite analogous to the Fluent case and data files. We don't have that implemented with sizzle data files yet, so you will be creating one file that contains all the time steps today, but we'll work on that later.
And it will take advantage of sharing, right, if it's a common grid. So it won't necessarily be duplicating the grid, but it is required to be in one file. Yeah.
Okay, any other questions there before we move on?
No, I think you got that one.
Okay.
Yeah, thanks.
All right, so the advantages of using the TecIO library are that you don't have any intermediate file formats or conversions to perform. You get your sizzle data directly. The compression in the case of unstructured data will save you some disk space. Scott, what would you say is a typical compression for, I don't know, a brick data set with 8 or 10 variables?
We've gotten on our various tests anywhere from 30% to 60% compression.
Yeah,
So it can be really substantial. Yeah.
Yeah, I'm averaging about 40%, Dave, most of the things I've looked at.
Okay,
Yeah.
thanks. And to make this step as easy as possible, we've designed the new TecIO library to be a drop-in replacement for the old one. I'll demonstrate that in a moment. Cons, of course, as we mentioned, it doesn't work for data files that you already have. This is just for creating new ones. And as I just mentioned a moment ago, we don't have the separate grid and solution files available yet for the sizzle data, but that hopefully is coming. So let's do a really small example, again, because I don't want you having to wait around too long to watch this, but I do want to demonstrate how the new TecIO file library is a direct replacement for the old one. We're just going to do a 100 by 100 by 100 brick zone. So we've got roughly 1 million bricks, and for PLT output, as you'll see, it takes about 11 seconds. For subzone PLT, about 14 seconds. And so let me minimize this, and I'm going to have to navigate over to this folder. Okay, so brick.exe is the executable. It was built from brick.cpp. Let's have a quick look at that data file. I think I've got it open in an editor already. Yeah, here it is. So this is a C or C+, I think it's a C file that was renamed to CPP. We've got some, this is our main routine where we're setting the data up. But I wanted to show you the particular TecXXX functions or TecIO functions that were called to give you an idea of what it takes to create a Tecplot binary data file. First off, we call TecINI112 to basically to pick a file name and enter the variable names and a few other things that are of less significance now that we're just setting up the data. Then for each zone we call TecZNE112 to pass it all the metadata about the zone size and the solution time, and whether it's sharing variables or connectivity. Then finally, we have to call TecDat to output the variable data and TecNode to output the connectivity. And then finally, TecEnd to tell the TecIO library that we're done writing data.
So you only have 5 function calls to...
Yeah, 5 APIs will be called here.
So Dave, before we go on,
Mm-hmm.
most CFD codes are still written in Fortran. How does this work in Fortran?
It works very much the same. The TecIO library has both C, C++, and Fortran interfaces, so you would see exactly the same calls in a Fortran code. As a matter of fact, we'll be delivering 360EX with a couple of Fortran examples alongside the C or C++ examples. So let me first off run this with the what I guess I could call the legacy TecIO library. I do that just by copying it into the same folder as my executable. So now on Windows, Windows will preferentially load any local DLLs before it loads any others. So I'll just launch this by double-clicking on it. It's a batch code, so all we're going to see is a DOS window while it runs, and we get some diagnostic output, which I haven't added to the new library yet. But it's created brick.plt, which, as you can see, is about a 40 megabyte file. Now to write the new file format, I just copy the new TecIO.dll, same name, same APIs, and overwrite the existing one. And now when I run brick.plt again, you'll see we're not getting the diagnostic output we were getting before. Might be nice if I added some of that. It's on my to-do list. You'll note if you started your stopwatch, which you probably didn't, it ran a few seconds longer. And it created the main scplt file plus these auxiliary files for the 4 variables. We're thinking of rolling all of these into a single file. We just haven't gotten to that yet.
I think we have a question on that.
Okay.
So it says, asks about the number of scplt files. Is it dependent on the mesh size? And can you get an excessive number of files?
Well, as it stands today, you get one of these SC tree files for every variable, but you get only a single scplt file. If I have my way, we'll roll all of these together, so you'll just get a single file.
But if you have 100 zones in your file or 100 time steps, it doesn't create additional
That's
files.
right. You get just a single scplt file and one SC tree per variable today.
And that's probably the direction we are going to go, Dave. So
Okay. I don't
so
get my
whenever
wish.
you want to roll that sucker in, go right ahead.
Oh, okay. I might get my wish. Good.
Your wish is granted.
All right.
Make it so.
And then looking again at the file sizes, the original brick.plt, the older format, is almost 46 megabytes. And if we add up the scplt plus the fairly trivial amount for the tree files, we're still well under 30 megabytes combined. So we're getting some fairly good compression there.
There's a question, any issues with big data and 32-bit indexing?
Yes, it's the same issue that we've had for a very long time with 360. We're limited to about 2 billion cells right now.
Per zone.
Per zone, yeah.
Yeah.
So if, let's see, do we have a slide on parallel issues later? I don't think so.
I think we do.
Yeah. We do.
Oh, do we? Okay.
Yeah, so we have done up to 30 billion cells, but it does require breaking your data down into multiple levels. So that might have 15 zones, and then each zone is broken into subzones in order to do that. So it's eventually that will be taken care of.
Yeah. So we demonstrated the current state of outputting our subzone-loadable PLT files. I'd like to talk briefly about future directions. You just heard Durrell give me permission to roll all the SC tree files into the SC. Yeah, I've got it on tape now. You can't take it
We're all
back.
witnesses.
So hopefully those auxiliary files will go away soon. But the other future directions is outputting separate grid and solution files, as you can do today for PLT files. which will be advantageous for transient flows where you have non-moving grid. That'll be a nice option. You'll be able to drop a solution. You'll be able to have your solver drop another solution file for every time step, rather than having to output all of it and then translate it later. For domain decomposed, as we were talking about a moment ago, this is common with massively parallel simulations. You have an enormous zone, but you break it up into, I think, typically 50 to 200 million cells per calculation node. And we'd like to have better support for that so that you can have multiple nodes writing different pieces of a single zone, and yet have all those come together, have those be separate files, but still all come together as a single zone in 360. To do that, of course, we'll have to address the 2 billion cell per zone limitation within 360, and also implement the multiple files per zone format as an extension of the current SCPLT format. We also want to make these files more accessible to your processes, which in which you know, 360 is probably not the only executable you have that needs to be able to access your simulation data. So we'd like to produce some reading APIs to allow your internal codes to query Sizzle data files, and so you can use Sizzle as your one data file rather than having to, you know, keep your Plot 3D data files or whatever around just because you know how to read those. And then, of course, once we're writing files that overflow the 32-bit signed integers, which is, as I said, about 2 billion cells, we'll need to add new APIs to allow you to enter those larger, for example, the zone sizes in your call to TecCNE, because currently all the TecIO APIs take 32-bit integers. So we'll have to expand that to 64-bit integer APIs. It looks like we're getting more questions over here.
We have a couple more questions, and then Durrell wants to show something. But one of them is, will the SCPLT files help with redraw time? And I'll take that one. At this point, no, they don't help with redraw time after you rotate, for instance. So if you're rotating and it redraws slowly, it won't help with that. But there is, during the rotation, there are techniques available in Tecplot to speed things up, and that is you go into the options dialog and select select what is it, approximate grids.
Yeah, we can actually walk through that.
Yeah, and that'll speed it up pretty dramatically for you. It'll take a couple seconds to generate the approximate grids, but that's much faster. And then finally, with the new TecIO library, can I choose to write the old style PLT file?
No, we don't have writing both formats in a single library. That's a possibility. I guess I'm struggling to understand what the utility of that would be. I guess if you have workmates who are using older versions of 360 that therefore can't read the Sizzle files, you do always have the option of writing older formats from Tecplot itself, though.
Right.
Okay, I think Durrell had another... well, I was going to just show some of the results, so I'm going to swing in here, Dave.
Okay.
Like musical chairs for a second. I'm just going to maybe walk through a couple examples of the speed-ups, truly uncached, which is always nice, because I just actually did this. That's when it doesn't work. All right. So we've kind of shown you how to load the data. I wanted to show a couple of larger files. We've done this a couple of times in the past, but I think it's worth showing here today. So I'm going to load in a file. In this case, it's about 190 million cells in the SCPLT format, just to give you an idea of what the performance improvements are. And you can actually Currently, we have a profiling mechanism. It will likely not be released with the version that goes out commercially. But we use this internally to help us understand effectively how fast or what kind of performance improvements we're seeing. So I'm going to profile the opening of a layout. And yesterday I was fortunate enough to get another disk drive in my little laptop by replacing the optical drive, which I think is becoming very common, because I don't remember the last time I put an optical disk in there. Actually, I don't even know if I could find an optical
Jobs was right.
That's Steve character. So there's a couple of examples we could look at, but we're going to go ahead and start by just looking at that transport airplane example. And we're looking at a slice using the new SCL PLT or the SC PLT format. And basically what we're doing now is we're going to be loading it off the disk. This is a slightly slower disk. That's the disadvantage of a laptop. So this is not off my solid state disk. This is actually just off my good old-fashioned, I think it's 5,000 RPM, something like that. It's pretty slow.
Yeah.
So whereas on my my solid state disk, I can usually get this done in 3 to 5 seconds. On this disk, it looks like it's about 13.7 seconds. So.
And to be clear, though, this is actually loading the data and creating the slice. All of that in 13 seconds, which is, it's probably 2 orders of magnitude faster than if you
at least.
If you had to load the full
How big is this data set?
This data set, as I recall, is about 185 million cells.
Okay.
So it's pretty substantial. The other thing that we realize is that as you go through and you create an additional slice, it has to query the subzones, and so in that context, it is slightly slower. I've noticed it's about 20% slower than if you had all the data loaded initially. However, with a legacy format. So to give you an idea, and it takes a little longer, so I'm going to fire up a second session so we don't have to waste time watching it spool. But we'll profile the opening of a data file. In this case, we're going to be looking at the PLT format. And it's important to point out that you could load that data, and that's I know that some people have said, oh gosh, I have a 200 million cell model, I'm not even sure if I should open it to begin with. But as I'll show you, it's quite possible to both open and work with data files of this size on a typical engineering workstation.
And to be clear, we've actually been working on improving this as well.
Sure.
With the standard PLT files, we have up to a factor of 2 improvement. Depending on what you're doing.
Yeah.
And we've done comparisons against other visualization packages, and we compare very well with them. In most cases we're faster, some cases maybe a little bit slower, but comparable, and not this is with PLT, we're comparable.
Absolutely.
With SCPLT, we're much faster.
Yeah, it's pretty significant, and I think someone had brought up, and I guess it was David who brought up, or was it David or Kyle, had asked the question about performance. Under options, there's performance, and if you use approximate plots, basically what it does is grid decimation, which, as Scott pointed out, initially it has to go through and do that decimation, but once you actually have it, when you rotate, you could see that you're actually rotating less data, but as a result, it's extraordinarily snappy.
And then just does the full redraw when you let go of the mouse.
Yeah, when you let go of the mouse, it pulls the data in. Now, you can, in fact, for very fine mesh, sometimes there's an advantage to leaving it on permanently, which basically is an option. So if you choose, you could actually go into performance, and you can have this approximate all the time. And that just basically makes it so that it doesn't refresh all the data. So.
And actually, when you do that, a redraw, if you push the redraw button on the side, I believe it still does.
It should, yeah. Once you hit redraw once, Drew.
Let's give it a go and see if it works.
Yeah. So there you get the full plot, but you have to hit redraw, or otherwise you will see, what file can't I read?
Okay, well that's just...
So it just the other Tecplot just finished loading the initial layout.
So at about 113 seconds.
We have another question, and perhaps Dave can take this. Does the TecIO library support parallel I/O?
I'm going to say no. I mean, you can have different nodes writing to different files, but let me think. Let me make sure I'm accurate here. Because our sizzle or SCPLT files, your solution today needs to be in a single file. We haven't implemented multiple files per zone. You'll typically do what you do already probably if you're writing out PLT files, which is to have a single I/O node and have your different compute nodes passing data to the I/O node to write out to the single file. Did I miss anything there, Scott?
Yeah, there are people who currently with our current TecIO will write to separate files.
But that means they're creating separate zones.
So they're creating separate, yeah. So they have a domain decomposition, and they write those domains into separate files, and then when you load it into Tecplot, you have to load those separate files simultaneously, which you can do with Sizzle, and then you.
But you wind up with separate zones.
But you end up with extra zones. But it's an option, and that is something that we want to work with people on in the future. And this is
as a matter of fact, if any of you are in this situation and you're interested in helping guide our future direction here with regard to massively parallel computation data output, we'd love to talk more to you about that.
And similarly, if you're interested in our beta program, you can pop over to Tecplot. Well, that's interesting. Look at that. It's got music.
That's just awesome.
I'm sure someone thought that would be great to put their CFD results to music, but anyway. So if you go to the main page and click on the Tecplot 360EX, it'll bring you to this page, which you'll see there's Join the Beta Program. And we're pretty liberal. I mean, all we ask is that you give us information about who you are, and you can have access. We also have it puts you into something called Basecamp. There you go. Actually, it's right there. And in Basecamp, there is a project that basically we use for the beta program, and basically allows you to ask questions or post suggestions. And we try to be very responsive in terms of if you have a good suggestion, if we can try to put it into what we're doing, we try to do that as quickly as possible. So I'd encourage you to go ahead and sign up for the beta program. We'd certainly like to have you there. I did want to quickly talk about some of the other improvements, just so that for those people who maybe have asked for these things in the past. And actually, probably the easiest thing to do would be to quickly show you this. And again, if you have questions, we have a few minutes for questions. We'll open up to general questions in about 3 minutes here. So quickly, you can see that there are several types of slices one can create. We're actually going to look at a slice through the volume zones for a moment, and we're only going to show a slice for simplicity. Okay, so we have a slice, and actually I don't need to mesh at this point. Okay, so we have a slice on the wing. This is a simple UAV case. This is an open source geometry. One of the challenges we have is we have lots of really cool data that we can't show you because many of the people we work with, the data that they create or generate is ITAR or otherwise under NDA, proprietary. So one of the things that we implemented recently, and let's see if I can put this in the x-axis. So if you're unfamiliar with this, you can actually change the axis of a slice usually by typing the letter of the axis you're interested in. In this case, I put it in the x-axis. Okay. We implemented arbitrary slicing. So in this case, we are, and then by the way, this is a beta. It is a beta, and so there's always the possibility that we could find a dark corner, but so I wouldn't worry too much about it. The final release will make sure that it doesn't have any drama in that case. But okay, so we have now, or should have, the arbitrary slice available. And basically, this is a pretty big data set. It's probably not the most optimal one to show, but we're going to, if you go into the details here on arbitrary, you can actually play with the origin. Maybe I'll bring this up say, to 30, just to see if I can get that to a different state. And one of the things that we're looking at is mechanisms to do extractions in a more convenient way. I'm still not seeing the interactor. Maybe the interactor's off scale here. There it is. Okay. So here's the interactor. I'll just move it down closer to the plane itself. And you can actually then rotate that slice, move this around, so I can grab the point here and actually orient the slice in any axes I want. Of course, I can do that via the dialog as well. So these are some of the capabilities we've been working on. Additionally, we've added capabilities around the right-click context menu. So if I click on an object, for example, if I clicked on the fuselage, I can put velocity magnitude as the contour variable very quickly. So those are just a couple of things. We'll actually have a couple of webinars where we'll go through in great detail on how you use some of the new capabilities. They'll be more tutorial-based, and that'll be closer to the release, which is coming up pretty soon here. And with that, I'd like to open it up to questions for those people who may have questions that weren't answered. We'll go ahead and open it up at this time. So again, to ask a question, one needs to go to the questions sidebar as part of GoToWebinar, and you can just type a question in there directly. I think we've kind of hit on a lot of the questions already. Let's see, there was a question here about reversibility, which basically people are asking the question if you can, I have data in Plot 3D, for example, Scott, and if I convert it into SCPLT, can I go back to a Plot 3D file?
Yeah, and the answer is, at this point, no. You can go back to a PLT file using Tecplot, but that is our intent in the future, is to make that possible to the extent it is even feasible, right? There are some file formats where we don't have the capability of knowing everything that was in the file. Mm-hmm. But for those formats where we do know what's in the file, that's something we will be looking at doing in a future release.
We'd also like to make it unnecessary by allowing your code to read SCPLT files. I think the reasons I'm aware of that someone might be interested in going back to a Plot 3D file would be if they need to share it with somebody who doesn't have an SCPLT reader, or if they have in-house codes that can read Plot 3D data. In the latter case, we'd like to enable your codes to read SCPLT files.
Yeah. There was a question about the anticipated release date. I think it's important to point out that it's still in heavy beta testing, and because we've ripped the code apart and tried to put it all back together, we're still finding errors like the one that we saw here this morning. So I'm hoping for April, early April, but it depends on a lot of things. We got to make sure that it's quite stable before we get it out there. That being said, we have a very open beta program, and therefore if you are interested in getting your hands on it in advance of the official release, you're certainly welcome to do so. Yeah. And as long as you do it with a grain of salt, meaning that if it misbehaves, as it did a moment ago, you just have to understand that that's being worked on as we speak.
We have a question about macros. Can you use your old macros to go through transient solution files with SCPLT files? Yes, with caveats. First of all, you'll have to change it so it reads an SCPLT instead of PLT. So that'll be a modify to your load data macro, right? And then the second is you might want to turn off anything that would extract an outer boundary if that's in your macro, just unless you truly need it, because that'll slow it down. So those would be the two caveats. But definitely the vast majority of the macro scripts will work just fine with minor modifications.
Now, and another very common question around data formats, at least that we've been running into, is, well, I don't want to move my data from CGNS, just want to leave it there. Will this technology improve performance with just CGNS files, for example? And I think that the short answer to that is, at this point, you do need to convert it. Again, going back to the indexing and domain decomposition using orthogonal bisection. But That being said, we are looking at some strategies to perhaps extend some of this indexing to CGNS files. I don't know if you want to comment on that, Scott.
Well, it's vaporware right now.
It's vaporware, yeah. We don't really have anything for that at this point, but it is possible we might be able to at least reduce the amount of memory you use. I do think, though, that in order to get the performance gains we're looking at, you're going to need to go to the new format. You may get some performance gains, but it won't be the same level of performance gain.
I suppose further out, CGNS itself might incorporate a subzone-loadable data into its format, but that'd be several years out, I expect.
Yeah.
And we're quite active with the CGNS committee. I know,
Yeah,
Scott, you're on the.
I'm on the steering committee, so it's we would have at least a say in such a thing.
And we have time for maybe one or two more questions. So if you have anything that you want to add to the conversation, feel free to do so at this point. Otherwise, we're going to be finishing up in maybe the next minute or so. So it doesn't look like we have any outstanding questions. First, I just want to thank Dave and Scott. Thank you for coming in and talking about this morning.
A pleasure.
Thank you.
It was a little earlier than we usually do these. It's 8 o'clock on the West Coast, so.
For a software developer, that's just obscenely early.
We were talking 8 at night. Now we're talking. So I'd like to thank all of you who participated. The recording will be available online likely by this afternoon. There were a couple of requests for both the presentation and for the papers, and I will coordinate with our internal resources to see if we can't get those out to you, or at least links to those out to you so that you can take a look at this technology. Again, thank you for your time this morning, and we look forward to our next webinar, which will likely be in early April. And there are two things that we're looking at. We haven't kind of solidified. One's going to be working with a partner who does immersive boundary data. This is Carolet Technologies, so we're doing a joint webinar with them. And we will have another more tutorial-based Tecplot 360 webinar in the early April timeframe. So thank you again for joining us, and we'll see you at the next webinar.